Let's move towards today's problem of the day. It's not that tough question, but yeah, might help you learn something new, especially when you have to deal with directions like moving up, down, north, right, and those sort of things. Let's directly jump towards the question. Yeah, I just solved it. Yeah. Let's read what the question is. The question says that a robot on an infinite xy plane starts at a point 0, 0 facing north. The robot can receive a sequence of these three possible commands. So the command can be -1, can be -2, and it can be an integer between 0 to 1 to 9. If it is -2, then it has to turn 90 degrees left. So basically, if it is not, like initially it is pointing towards north, then it will uh, start pointing towards west, right? So, and yeah, similarly this one, you have to turn 90 degrees right. What now? Some of the grid squares are actually obstacles. The ith obstacle is at grid point this x1, y1, xi, yi. If the robot runs into an obstacle, then it will instead say in this correct. Basically, if there is an obstacle, then it will not. Obviously, it will not move towards it, right? So return the maximum Euclidean distance. What is Euclidean distance? Distance squared. Okay. Yeah. So first, let's see what the question is saying. So basically, if you are initially you are at 0, 0, and let me change it to red. Yeah. So initially you are at 0, 0, and if you get -2 as a command, then basically if you're pointing there, then you're now pointing there. If you get -1, then you'll point there. So what we are doing here is we are assigning a value to each of these directions. 0 for up, 1 for right, 2 for down, and 3 for left. Okay. So either you can turn 90 degrees left or 90 degrees right. So basically what I'm doing here is if we get -1, then we'll add +1. Where we'll add +1 to the direction. So let's say if you have originally you have direction 3, which means you're pointing yeah, let's just move towards a clear board. So basically if you're originally pointing in this direction and you get a -1, then you will be pointing here. So basically from 3 you will go to 0, and from 0 you will go to 1. From like if we keep getting -1, right? From 1 you go to 2, from 2 you get to 3, and 3 again you go to 0. So basically what we can do, we can do direction +1 mod 4, right? And for -2 what we can do, so like if you are at 0 you have to go here, right? So basically either you can do -1 or you can do +3 mod. So basically -1 doesn't make sense because we don't have a direction -1, but 3 does make sense. Basically what we are doing, we're doing +3. Let's say you have +3, you're already pointing here, and if you get to -2, then you'll be going here, right? So any +3 mod 4. So for -2 what we do, direction +3 mod 4. This is what we do. All right. Yeah. Then once we finalize a direction, we can get an integer k. For k, what will you do? You'll move in the directions. Let's say you are already pointing towards the right, then you will move k distance from your current point in that direction, unless or until you have an obstacle in between. So yeah, this is the thing. So how will we change the coordinates? Let's say our current coordinates is this. If you have to go upwards, then like k distance upwards, then you will add plus k to y and 0 to x. Similarly, if you have to go there, then you have to basically do this, add k to this. If you have to go down, then you will do x comma y minus k. If you have to go left, then you will do x minus k comma y. So basically in one unit time, you will be doing x minus 1, because it can move one distance in 1 unit. Like if you're not yet clear with the question, you can read the question once again. So basically with the directions, if the direction is 0, then we'll do x comma y plus 1, right? So basically 0 comma 1, this we will add to the current coordinates. And if you go there, right, you will go 1 comma 0, you will add this. Otherwise for down you will add this, and for right you will add this for 1 unit time, and you will keep repeating for k unit times unless you get an obstacle. So you're given a vector of vector for obstacles, right? Something like this. So for every coordinate you'll have to check whether that coordinate is not present here, right? But you cannot check directly using the vector because it will cause a lot of iteration, because we cannot directly jump towards a conclusion whether a point is present there. So what we can do, we can use a set or a map, something like this, to store these points. And yeah, that is what we can do. This will be searching in big O of log n. Another thing what we can do, we can basically create an unordered set or unordered map, and this will fetch our boolean value whether it is present or not in big O of 1, but you cannot actually directly store a coordinate like this. Like, you cannot store a pair of int comma int. What you can do is you can convert this into a string, and then you can store it here. All right, I think now the question is clear. Let's move towards the code. So what we are doing in the code, we are initially creating a map. So whenever a pair is present, we'll establish its value as 1. So we'll basically iterate through this obstacles vector, and for every pair we'll store the value 1 for that particular value. Then we have declared a vector directions, and for 0 you will add 0 comma 1 to the coordinates per unit time, and so on. You have an answer, we start with 0 because the Euclidean distance at the start is 0, right? You're standing at 0 comma 0, and the direction is 0 as you are looking at the north. So then we iterate through the commands, and we get the command for that particular index. For command is equals to -2. What we do, direction plus 3 mod 4. That is what we discussed. Yeah, here for -1 we do this, right? For -1 we do this, and then other than that, what we do, we move towards that particular direction for k seconds. So basically we can place this with k. For a particular direction, what we do, we assign the new why is it, yeah, so basically what I was saying, yeah, so for a particular unit time, what you will do, if you're pointing upwards, then you'll go 1 point upward. That 1 or 0 we'll get from this that we declared here. So basically after every unit time, our new x and new y will be this, and if that is an obstacle, we'll break this for loop, we will not move forward. Otherwise we'll keep updating our index and the coordinates, and for every coordinate we choose the maximum value, right? If it is greater than or not, like the previous maximum value, whatever it was, if it is greater than, then we when we establish a new answer, and then finally we return our answer. Yeah, was not that tough. I think I hope you understood each of the concept that I discussed. Thank you. Let's see you on the next question.